Okay, wonderful. We're ready to roll. Hello, everyone, and welcome to another webinar by PerfectScale, by DoiT, I should say. Another one of those webinars where we invite the most interesting folks in our industry to talk about all things DevOps, Kubernetes, infrastructure automation. And today I'm very happy to have Adam Jacob with me. Adam was one of the first proponents of infrastructure as code, the original author of Chef, the founder of the company that stood behind Chef, originally Opscode, right?
Yeah, and then also called Chef.
And then also called Chef. And now Adam is also the founder of System Initiative that was launched last year, right?
Yeah, we launched the public you've been able to use System Initiative since late last year.
Okay. And Adam has opinions regarding where the DevOps automation is going and how it's changed since 16 years ago when Chef was created. So, Adam, I'm very happy to have you with us and very impatient to hear what you have to say.
Well, thanks for having me. Yeah, no, I have so many opinions. I'm also joined by Nick Steinmates. Wave Nick. Nick's gonna help me
Hey,
out in a
Nick.
minute when we get to demos. And and if he feels like it, he might chime in and add a little bit of extra color as well.
I'd never do
Yeah.
that.
All right, so let's get to the thing. So I think
Yeah, I'll stop my sharing. Here you go.
a good way to think about the industry or in general, you talked about infrastructure as code, roughly 16 years worth of history. I go back a little further, I would say like a lot of the shape of what we've been doing kind of gets started, let's call it the late 90s, right? So 98, 99. I kind of start the clock from CF Engine 2. Um, and I think one realization that I came to sort of post Chef, well, toward the end of Chef, and then certainly after, is that we've really stalled in terms of our progress with applying automation to our technology problems. If you look at the results we were getting 10 years ago, in terms of like how teams were accelerating, what it felt like to do this work, yes, it was less distributed. There were fewer people who had like experienced that automation. But if you look at the results we were getting from 16 years ago to now, we're getting roughly the same results, even though we've had this like ridiculous explosion in terms of technology, right? So if you think about how much stuff we've added to the stack and how many things we've changed and how many new implementations we've made, and then you look at like the Dora report and you go, okay, how many people can actually deploy an application once a week, And we're still, let's call it 80% can't do it, right? Or their failure rates are super high. And that is because we sort of have this highly complex, interdependent web of automation. Every time we add something to the stack, anytime there's a new technology, anytime something new happens, we wind up having to figure out like, well, how do we glue that thing in, right? And then each individual implementation, if you look at any individual company, like the way they think about their automation is always unique, right? Because they've made choices about all the different pieces that sort of come up across the stack. And so the end result is that we're kind of stuck in this mechanism where kind of no matter what choices we make, we tend to revert to this mean of kind of mediocre outcomes.
Okay. Even though, infra as code has been evolving,
Yeah,
like there is Terraform. Okay. You can
totally. Yeah. And that's the interesting part, sort of regardless of the technology evolution, right? Like we've had cloud, we've had Terraform, we've had Pulumi, we've had Kubernetes, we've had like there's a ton of technology we've applied to this problem. The actual outcomes, not better, right? Basically identical to what they were before we had them. Which, in one way is kind of amazing because you're like, we held the status quo. And also there was this big leap forward and then a very long stall in terms of improvement. Because if you
Yeah,
think
one could
about it,
say
like,
like
go
DevOps
ahead.
was like a tectonic shift, and there was no no shift since then.
Yeah, kind of, right? And we sort of been just sort of not resting on our laurels, but like sort of believing that there was more to be gotten here, like there was more juice left in the for the squeezing. Perhaps that's a weird analogy, but like, when you look at the stack, this is sort of the bare minimum of stuff you have to think about in order to get to some kind of automation broadly, right? And it's basically the same list as one we had in 2008. It's also roughly the same list we had in 1999, although the words were different, right? So like we weren't really talking about CI/CD pipelines in 1999. Instead, we were talking about like application deployment, or we were talking about like QA, right? But like mechanistically, like this is sort of the same basic stuff. And you probably have answers to all of these questions inside your organization. You probably made bespoke choices. The most common thing here probably is now source control, where like you probably have source control and it's probably Git, you know? But if you look at the rest of it, it's kind of wide open, right? In terms of which choices you make, and you make them for good reason, right? Like you choose one thing or another usually because there's some feature, there's some piece of it that fits your problem, right? Or fits how you think about the problem. But the outcomes in the end sort of revert to the same place. And it's because, the integration between those choices is always code, right? Basically, our underlying theory of how this system can work starts with this basic truth, which is we're going to pick all this different pieces of software. Then we're going to figure out how to glue them all together. And we're going to do it with infrastructure as code. We're going to do it with scripts. We're going to do it with writing policy pipelines. We're going to do it by writing Helm charts. We're going to write Kubernetes controllers, whatever we're going to do. We're going to like write code to try to tie it all together. Um, and we're trying it in a bunch of different ways, right? So, there's people trying the sort of platform abstraction approach to move it forward, right? So we're going to go build developer portals and then other tooling underneath those that tie it together, sort of thinking that the problem is how hard it is for an engineer or someone else to consume all this automation, right? Which, fair enough, that's a problem, right? You have, the PaaS approach, which is like, the problem is too many options, right? We don't need all these options. 99% of the world can be built the same way. So the Herokus and the Cloud Foundries and the Railways of the world are sort of making this argument, right? You have the like Kate's maximalist argument, right? Which is just like, fuck it, it's another controller, Like everything is Kubernetes. We're just going to controller our way to heaven. You have sort of
Everything
infrastructure.
is an API.
Yeah, sort of, right? A very particular API with a very particular behavior. But, you have infrastructure as code sort of maximalist too, right? Where they're like, hey, the problem is that it should all be expressed as declarative code as opposed to declarative whatever declarations. You have serverless people who are like, hey, the problem is that the programming language is too far away from the services, right? So if we could just put the programming languages first and then have the programming languages call the services, then that would be better. You have sort of the AI camp, which is like, hey, like let's just have the robots sorted out. Like we're gonna throw all this information at some LLMs and then maybe they'll just solve for this problem. But,
You wish.
interestingly enough, kind of all of these ultimately are failing to actually move the needle on the larger outcome. They might solve some specific problems, right? If you don't have a developer portal and now you do, undeniably that's better, right? If you don't have infrastructure as code and now you do, undeniably better, right? You're not using a Kubernetes and now you are, maybe your life got better, right? But, the actual outcomes, kind of the same. And when you think about like AI, it's good at transforming information from one shape to another, right? If I give you a sentence and you can give me code, right? I can give you a description of an image, you can give me an image, right? It's incredible at doing that. But without some more innovation, if you look at the problem, what we're going to ask AI to do is try to understand all of these different systems and how they interconnect with our specificities and like that's not what it can do, right? That is not what it is good at today. Like it's precisely actually where AI falls apart is when we're like, hey, I have all this data. Awesome. Now I need to make really complex choices about the specifics of how my things behave. Give me a very specific outcome of which there's probably a very small number that actually work. Like this is not where AI thrives, right? And and this is all kind of because there's no model for any of these things to use other than I'm going to write a bunch of code that sort of describes how to glue together all my choices. And so even if you wanted to have the robots do it, like what's the model that we're asking them to understand? Like how do they understand what's available and what technology they could possibly automate? Um, and so what we need is sort of a fundamentally different theory of like how automation even works, right? How do we even think about this problem? Not so much just as this intractable software problem, but instead as a theory in and of itself. So when we talk about sort of theories in programming, kind of what
Yeah.
we mean.
Adam,
Yeah, go ahead.
just I just want to encourage our audience to send us questions. So we have
Oh
the
yeah.
Q&A in the webinar. So please do send us questions, and I'll serve them to Adam whenever appropriate.
Yeah, I love to be interrupted. Like, please. Like so much more fun if you talk to me than if I just talk at you, right? Okay,
Okay.
so when we talk about theories, like in programming in general, there's sort of three things that theories give us, right? So one is they explain sort of how the solution relates to the outside world. So it says, hey, I have this problem in the world. Here's this solution I'm proposing. We can talk about how that solution then sort of relates to the thing we want to see in the world, right? I want to have some infrastructure. What's my theory of how I do it? Well, my theory is I write some infrastructure code with Terraform, and then it does the declarative loop, which then goes to an interpreter, which then manages state and sort of comes back around. Or, I use Kubernetes, and so what I do is upload a manifest, and then the manifest gets executed by a controller, and the controller runs a loop, and then the loop tries to reconcile, and then we figure out what the loop is, right? It also lets us talk about how the program works under the hood, right? So I was just rattling off like how Terraform works and how Kubernetes works, right? And that's because I have the theory of how they work in my head, right? Um, and then finally, we can respond to demands for modification. And this is where the most interesting piece of theory building actually comes from. When you say, hey, I need the program to work differently now, I need the system to do something it wasn't designed to do yet. How do we change the system to match the new requirements? And in a lot of ways, that's where the current theory of how we do this falls apart, right? Because what we're saying is at every turn, it's, well, think about how that integration can happen, right? Figure out how it sort of fits into all this other big piece of puzzle, write a bunch of glue, and sort of pray. So, what would a different theory of automation look like? So, we have one that's called infrastructure as model. Um, and essentially, it has an implementation. We implement infrastructure as model on top of what we call a hypergraph of functions, right? And so what do I mean when I talk about sort of infrastructure as model? So the first one is that, the word model basically means a high fidelity representation of a real world thing. So usually when I say model, what programmers tend to think is data model, right? They think like MVC. And I mean that as well, but in a deeper way, I mean sort of what is the shape of the information that we're trying to do in the real world, and how do we model what that thing can do and be, right? So when we talk about infrastructure as model, what we mean is we're building virtual representations of the things we want to manage, the infrastructure we want, the code we want, the platforms we want, and we're building those things up into a model, and we can operate on that model. Okay. The model is a reflection of the world. And when we talk about it, we tend to talk about those as domains. So the world is, you can sort of break it into this idea of a domain, which is like, for in our example, it's the domain of automation, right? So we choose to work in automation. Therefore, we build a model of how automation gets constructed and how we think about building that automation across these models, right? But the model's job is to reflect the truth inside the domain. So back to that question of like, what's a good programming theory, right? The number one way you know it's a good theory is because you can relate how it works to the actual problem in the world, right? And you do that by sort of thinking about it in terms of the domain. So here's an example of some other domains where we use a similar approach to solve complex problems. So for one would be Formula One. So the Formula One season is starting today with testing. It starts tomorrow, actually, with testing. So there's 3 days basically where the first 3 days that these cars get to like be on a track. And if this was the very first time that those cars have ever run ever, that would be very bad, right? Like you would have a very bad day in Formula One testing. And so what they do is they build really high fidelity models of the domain of Formula One. So they basically model everything about the car, right? Tires, aero, the driver's weight, right? All of those things get modeled in these really high fidelity systems, and they build these incredible simulators. And so rather than running the car for the first time when it comes to the track, they've run the car thousands of times virtually, right? Over and over and over again. And then they use the data from this simulation to inform how the car should be set up when they take it to the track. So when that car shows up in testing on Wednesday, it's actually run that track millions of hundreds of thousands of times probably, or at least thousands, right? I don't know how many it's actually run. That felt hyperbolic, so I kept backing myself down from millions to hundreds to thousands. Let's call it thousands of times. But you get the point, right? So essentially they build a digital twin of this car, and then they race this and the track and all of the different variables, and then they use that to decide what it should be.
Interesting.
More pertinent to our domain is Unity. So Unity has a model of how we build video games, right? So rather than starting for scratch about saying, let's build a video game and just opening VI and being like, let's go, which is roughly what we do today when we're building infrastructure automation, Unity has the shape of all the different things that go into making video games, right? It understands like scenes and models and shaders and events and scripts, and all of those pieces of the fundamental bits of the video game happen in this model. And when we're programming Unity, we're really programming this engine that understands how to turn itself into a video game, right? And that engine, in many ways, is what's missing from our current conception of how we think about automation and how we do sort of DevOps in general. Does that make sense?
Eh, well, it does. And then, the original infra as code tools, they also had their own models. Like there were all of those objects that you were
Yeah,
managing and
sort of.
dependency graphs and
Yeah, kind of. The difference is that like it's a good question, right? But they don't actually. So like when you think about the difference between like a declaration in let's use Terraform as an example, right? When I write a declaration in Terraform, that code absolutely gets compiled and sent to an interpreter, right? And then the interpreter understands what your declaration was, looks at the outside world, manages some state. But that's about the execution of that code. What's different in Unity or in like a simulator in Formula One is that what you're doing is storing information about the game, not as code, but as information. And then we're using that to generate the code, right? When you want to write a scene in Unity, you don't open your editor, write the scene, then see it show up in this UI, right? You interact with the information that you're feeding the system so that that can happen. That interaction layer does not exist for us right now when we think about automation, right? Like there is no such thing. There is no meta layer that says, hey, here's how we think about modeling the equivalent of a scene, right? Like all we can really do is be like, well, yeah, I can write code. There's abstractions in there, but it's
well,
not the
yeah,
same as having a model fundamentally of like how the system is going to behave, right?
yeah.
Do you see the
So
distinction?
we need to do the work of, we have this vision of infrastructure in our head, and we need to translate that to code, basically.
Yeah, and that trans and nothing helps us with the translation, right? Like think about it in terms of like Amazon launches a new service, right? That new service can do things. What can it do? How do we express it? Could you even programmatically, like just try to programmatically ask the question, what are all the actions I can take on this service? And you just can't get the answer. Like you can find a spec, right? But the spec is a mess, right? There's actually no way to really even understand it, much less like program it, right? So this lack of a model at the core is really deep into why we're struggling the way that we are.
Okay.
So if you think about trying to build a model for technology automation in the broad, right? That's really what we mean when we talk about infrastructure as model. And luckily, the way that we think about the shapes of that model are quite straightforward because they too haven't really changed since, let's call it the 90s. So you can basically think of it as I have things in the world I want to operate on. Those things have properties, right? So those are like their configuration, their settings, maybe some metadata, whatever it is, right? And we can imagine modeling all kinds of stuff this way, right? Servers, EC2 instances, load balancers, Kubernetes objects, racks, switches, ports, like whatever you want it to be. They also have actions. So there's things we can do to them, right? I can create them, I can update them, I could start them, I could stop them. And then they have relationships, right? So, this thing belongs to that thing. This thing informs that thing, right? So if we break it down with like an EC2 instance, right, it would have properties like a CIDR block or tags. I can create them, I can update them, I can also restart them, I can stop them, I can terminate them, right? Those actions are actually really hard to translate into, for example, infrastructure as code, right? Because it really only understands exists, right? Like exists or not exists. But there's actually a bunch more options we can do, right? It's just we can't express them well in infrastructure as code because those interstitial states aren't well understood. We'll get to that in a minute. And then it has relationships like, it's in a region, right? Or it has a lot of subnets, right? Um, so, okay. We build this model up from digital twins. So if we think about what that means, it means that we're tracking both the real world thing, right? So what is the resource in the world that we're trying to deal with? And what's the virtual representation of that thing that we want to operate on when we're in the simulator, right? And so we call the virtual side a component and the real side a resource, right? And what's interesting is that when you turn this into information instead of code, what you get is bidirectionality by nature, right? So right now, if you use infrastructure as code and someone goes and makes a change to a resource in the AWS console, you are done, right? Like it's a real problem because you got to figure out how to synchronize that state in a way that makes sense. In this world, you can make a choice about how you want to reconcile that information, right? Maybe you want to reconcile it by they did the right thing, and you just want to update the conception of what correct looks like by taking the resource's real value and updating your virtual component. Maybe you don't. Maybe you want to say, hey, the virtual component is correct. That resource is misconfigured. Let's go fix it. All of that becomes possible in a way that's much easier to do. And the trick to this is they have to be very high fidelity, right? So the more you try to abstract the resource away, right, the harder this becomes. So instead, you just model them one to one, right, as ugly as they are in real life.
Okay. So no single source of truth anymore.
Two sources of truth, actually. The real world is the truth about the real world. Yeah? Because that's always how it was. The idea that you had a single source of truth and it wasn't the world, what an incredible load of bullshit was that, right? And I sold that for a long time, and it was just wrong. It's crazy on its face, right? Like,
Yeah, it was also always a pain.
it was always a pain. Exactly. Um, okay.
And
So
still a pain, still a
it's
pain.
still a pain. So it resolves that pain for you by saying there's two sources of truth. There's what I think I want right now, and then there's what actually is, and they're both true in different contexts, right? Um, okay, that'd be great, but if the models were static, they're not very useful. So, if we're proposing a new fundamental theory of automation, it has to be programmable because we can't lose any of the power that we get out of the way we do automation today, right? Right? If you could make it easier, but I can't do any of the complex things I want to do, like that makes it worse. Okay, so we build up this model of what are called reactive functions. So this is a little bit of Vue code, but if you want to know how it works, the gist is we build a variable called count at the top that's a reference. Then later we increment that count. And then when we call increment count, what we get is the variable that's computed updating, right? So line 2 there, we're basically computing a value that says my value is whatever. That variable gets reevaluated the moment we increment count. Yeah. So instead of waiting, it happens automatically, right? So when we do this with like React or Vue, they use this mechanism to then go and update the DOM that shows in your browser what you want to see, right? So we do the same with this fundamental primitive of a reactive function, and we turn it into a graph. So basically, we say that the arguments to all these functions can change, and when they do, the function will run. So this example has us calling a function that just doubles a number, right? So the input is 2, which outputs 4. Then that goes to the double function again, which gives you 8. Then 2 double 8s gets you 16, and then there's a sum function to 32. If you change 2 to 4, it would just recalculate that entire pipeline of functions automatically and then evaluate the results for you, right? So through this model, you have properties. These are simple value computation, right? So you're just like, hey, you gave me an input, like a VPC ID, and I set that value to the output, right? Actions are things that have side effects. right? Side effects are basically functions where what they do is change something in the outside world that's not in the function's scope. It doesn't matter. Basically, you run a command, right? Or you hit an API in the outside world, right? So relatively straightforward to think about taking action. Relationships become argument passing and transformation. So you basically say, I have a property, a VPC ID, for example. I want to boot an EC2 instance into a VPC. How do I do it? So you draw a relationship between the VPC's ID and that same field in an EC2 instance, right? Then we insert this option to basically transform the value because perhaps I have information in like a container that expresses what ports the services are running on. Those are usually in the Docker container in an exposed ports field. Maybe I want to reuse that information in my Kubernetes declaration about for the load balancer because I know what the port numbers already were. This is what allows you to do that, right?
Mm-hmm.
We tie all that stuff together in what's called actually a hypergraph of functions. So the reason we call it that is because the hypergraph brings in this idea of change isolation and replay. So basically, you have this big graph. And what we can do is fork it into another dimension. And so we can say, like a Git branch, basically, we can be like, hey, give me a new change set. Now, when I make changes, I can track what changes I made to your dimension. And then we can turn that into a set of operational transforms that get replayed. So basically, they're auto rebasing all the time and we have a complete log of everything you've done. Okay, that's enough slides. So we're going to show you how it works. Do you have questions? So I can stop before I just keep trucking.
Not from me. There is a question from an attendee. It's about what do you think about the AI agents, but I think we'll leave it to the end. So I really want to see the demo
Yeah.
because this was theory. At the end of the day, I think, again, correct me if I'm wrong. I think you're
Yeah.
talking about changing the experience in the end. So
Totally. Yeah, the experience has to be dramatically reworked in order for us to have better outcomes. That's exactly what we're heading. All right, so now Keeb, Nick, who is also sometimes known as Keeb, so you might hear me call him Keeb. That's his nickname.
I keep.
So
Hello.
we're gonna do this demo together. So this is System Initiative. So this is the product we build, but it's all open source. You can also, but you know, it's an example of this theory in action. Yeah. So well, what we're going to do is basically deploy an application to an ECS cluster, right? So we're going to build a VPC, we're going to connect an ECS cluster to it, and then we're going to deploy the application sort of from scratch. And we'll just sort of, and we'll chat about all the different theory I've put in place while we do it. Yeah.
Yeah, and most importantly, we're going to collaborate on doing it. And so
Yeah, we're going to do it
I'll take
together
some
in real
turns,
time.
you'll take some turns. It'll be fun. Okay,
Yeah.
so if you click on my face in the upper right of your screen, it should take you to a change set, which is like a Git branch. What I'm going to
That's that
do,
fork, right? That hypergraph we talked about a minute ago.
yeah, I'm going to provision this VPC here. So I think we're going to deploy a publicly routable application, right?
Yeah.
So the VPC type here, I'm going to select as public only, and now I'm going to create it. And what you should see on the left-hand side of your screen is a new view just popped up. And
so you can think about what he just did as the equivalent of like what you see in like a service catalog, right? So we have like a template essentially that's building VPCs for us. We can build those on demand. It's similar to what you would get out of like a platformy kind of abstraction, but it's built into the same fundamental stuff as these underlying models.
yeah, so I think in this case, we have two public subnets, a route table, some routes, and internet gateway. So so the internet can reach our application. Yeah, so I'm just going to apply this network. And that's going to go off and start creating.
So you can see here this list of actions on the right. So what this was doing was basically keeping track of all the simulated things that we wanted to have happen, right? And now it's actually going and making those changes in the outside world. So it's actually creating them in AWS and sort of keeping track of the information. So talking about it as like both sides, like here's, you know, this is the component, that's our virtual side. Here's the actual resource. So here's the information from AWS about the actual resource as it sits in the world. Yeah. And what we just did was the equivalent of creating a new Git repository, forking a branch, writing a bunch of infrastructure code, right? Then than actually running that, seeing the plan, making sure that it worked, and running it all at once, right? So that loop, if you're familiar with it, we just did that entire loop in, I don't know, how long did that, it was not
5
very long.
seconds.
Seconds. All right, keep going, Keeb.
Actually, it's your turn. How about you create a
Oh, it's
change
my turn.
set and deploy an app? Okay, I've already created a module for you to do that, so you should just open a change set. Yeah.
All right, so I just created a new change set. I'll call it like PerfectScale app, and we're going to build a standard container application. So for
You got
us,
it.
this, we'll call it like PerfectScale. So this is going to basically knows how to take a Docker image and then deploy that to an ECS cluster in a VPC, right? So we'll call it logo. So it's running on port 80. Let's see, it's key SI logo. So this is just a little Docker container that basically shows the system initiative logo. So I just want to take a second and show one thing that happened here. So if you might have noticed, like when I was typing this, this box here was turning red. So what's happening is we have a function that checks to see if the Docker image is actually reachable, right? Does it exist in a repository that we've configured? So if you can imagine how many times you've like fat fingered the Docker image and then not known until you got all the way to the end of a deployment, right? Like you can write these small functions that will then show up in real time. So how that worked was there's a function whose input is the data about the Docker image, right? And then it knows how to go run Scopio to basically check to see if the Docker image is real, right? So, all right, so there's the Docker, there's the logo. So now we've taken some of this information and we've translated it, right? So this is an array of exposed ports. This thing takes only one Docker image, breaks it into port and protocol, right? So it understands sort of not only that there's information there, but how to translate that information from one thing to the other. So then we'll go ahead and create ourselves some infrastructure. So here we'll be like, hey, go build me one. So here what we have is an actual ECS cluster with a load balancer and a listener all attached, right? So it's automatically configured security group policies over here. Here's the IAM task. Here's the IAM role that the service needs in order to actually function. Here's the actual container itself sort of being deployed. And here's the list of all the actions we'll have to take once we're ready to actually go deploy the app. Okay. Should we apply, Keeb?
Yeah, you do it.
All right. So what's going to happen here is I don't actually have permission to deploy things in this workspace. So if you think about again, back to sort of different layers of infrastructure. So under the hood here, there's a Reebok system that understands all of these models and knows that I'm not allowed to actually change things in the real world. I can propose changes, but Keeb has to actually approve them. So I can go request his approval right now. In Keeb's view, he actually got a little pop-up that was like, hey, come approve this thing. Then he can go and review everything that we're about to do. He can look at the code. He can look at the changes to the different properties. And you can do that sort of dynamically. So he's approved us, so now we can apply. And if you've ever tried to build those systems sort of in the current automation landscape, it's pretty brutal, right? Because you got to think differently about how the policy engine works, how you scope to users, where do people come from? Like because we have this data model that understands all of this stuff we want to automate as information, it becomes a lot more straightforward to actually sort of put them in place. Yeah, so now we're off creating an ECS cluster. Yeah, almost done. Way to go, AWS. Okay. So if we come look at our load balancer here, usually it takes a second because the load balancers take a while to provision. So you can see that the sort of state of the load balancer here is provisioning. So we're just going to tell the system to preemptively sort of refresh that resource. And we'll just kind of keep doing that until what we look like is something we can actually.
Yeah, I think you want to show the audit log a little bit and
Ooh,
then
yeah.
also show how these things are built.
Yeah, let's do that while it's building. So under the hood, you've got this like every single action we've taken is in this audit log that's quite low level, right? So you can see it at the level of like someone set a property on an object, right? Or different values happened. You can see both the computed values and the ones that were manually set. So if you think about building the audit trail that you need in order to do like compliance and those sorts of things, by having this underlying data model, you can unify all that stream of information, right? Whether the data comes from AWS, right? When I was refreshing the resource, that's a thing that gets tracked in the audit log. It updates in real time, right? You can sort of see that stuff flow in and how you could build compliance systems on top of it. And then in terms of how you actually build them, um, they're just writing functions. So we can do this either from the command line in your own editor, where you basically just mount system initiative as a file system and then edit it like you normally would, or you can do it here from sort of inside the product. So, we have things like a load balancer. So this is the definition of a load balancer. If we wanted to, we could actually edit this definition. So we could click here, open it up. We could add properties to it, and it would keep track of those changes sort of across time. So even if new versions get published, you can deal with that. It understands things like, how to qualify itself. So for a load balancer, a thing you need to be able to do is have at least 2 subnets in at least 2 different availability zones, right? Otherwise, the load balancer won't deploy. So here's a function that's like 17 lines long that just encodes that truth. And so when we go look at load balancers, it knows what to do. And so a bunch of this gets built in from AWS's own spec, but again, if you think about it as just a programmable primitive, right? Maybe you decide that your, Docker images have to come from your internal registry, right? For security and supply chain purposes. And so what you could do is write a qualification on the existing Docker image, right? And you could say, hey, make sure that the actual path for all of our Docker images comes from our internal registry, and then disallow things that don't, right? And, most of these functions tend to be 20 lines long, right? They're relatively straightforward to write. Okay.
Our ECS app is deployed now.
Sweet. Yeah, so if we come back over here and look, we can see that the status is active, right? So the load balancer is actually up and running. So we can take this here and we'll go see it. Oh no, don't launch a meeting. That's not what I wanted you to do at all. Yeah, there you go. So sort of, in the time it took to have this conversation in the webinar, we basically went from an empty Git repository to running ECS clusters with VPCs in, not too long, while we were also kind of vamping. That's the power of thinking about this as a model instead of as just code, right? There's plenty of code to go around, but what you're programming shifts, right? Instead of programming the glue and trying to understand how all these things go, instead what we have is this model that gives you a conception of how to automate whatever you need to automate, right? So if we want to integrate with, like, say, PerfectScale, what we would do is just build a model of how PerfectScale thinks about itself, right? What are all of the different, pieces of that? Then we model that. Then once that's been modeled, now that becomes more information that you can track and use and tie together to program more and more complex schemes.
Mm-hmm. So there would be like a PerfectScale box that can connect to Kubernetes cluster,
Yeah.
and that in the backend that installs PerfectScale and sends all of the needed properties to that.
Yeah, you got it. And then if there's like command and control things you can do, right? So like, for example, like this HTTP listener, I think has some actions on it. No, what's a good one? Yeah, so target groups in AWS have a function to refresh themselves if they have changed. So if you change the target group, it's not enough just to update it. You have to basically enqueue this refresh action in order to do it. That's an example of something that in infrastructure as code, the only real thing it can do is tear it all down, right? It would just be like, I better delete the entire load balancer, take a little outage here, right? And then when I'm done refreshing it, we're going to do it. Here, it makes much more sense because you can just be like, well, yeah, there's an activity I know I can do to that object, which is refresh its target group. Its state will change, but I don't care how, right? I just care that it did, and I can track that it happened, and then we can keep making those decisions. So a lot more complex workflows can be expressed in this way because you've sort of broken through that that bottleneck of saying that there had to be a particular point of view about how the underlying system behaved, right?
Adam, there's
Okay.
two questions from the audience. One is, how does the model in AWS connect? Where does that happen? And the other is, how do we interface with AWS? What is the platform we use to
Oh yeah.
connect?
So we're I'm going to share my screen again.
Yeah.
So part of what's cool about the model is you can just go look. So if you want to see how we interface with AWS, let's look at that load balancer again. So here's the function that creates a load balancer, right? And what it does is take our model of a load balancer and then call AWS and create it. It's super straightforward. Um,
So
and
you're calling the CLI in the backend.
yeah, we're calling the CLI, but you could also call APIs, right? We could do it directly. We could do it however we wanted to. Weirdly enough, the AWS CLI does a lot of smart, useful work for you and has better coverage than even their first party APIs do. Um, a lot of the resources that we have actually come from what they call the Cloud Control API. So the Cloud Control API basically takes CloudFormation specifications and then knows how to translate those. So, and then there's maybe 300 AWS services. We have full coverage for all of AWS right now. There's maybe 300 of those services that don't have coverage from Cloud Control. And so those you actually just manage through using CloudFormation. So you basically just build a stack and then manage that with System Initiative. But yeah, there's no infrastructure as code layer under the hood, right? The model drives it directly.
Okay. And there was another question too, which was, which platform have you used to create these simulations?
I mean, that's what System Initiative is. So like we had to write it ourselves. So it's basically we use a lot of Rust in the back end. We had to build a sort of a custom graph database and a custom graph representation. Under the hood, it's basically working in this idea of sort of immutable snapshots. So everything you do is actually creating an immutable snapshot of the graph. And then we're calculating operational transforms between those immutable snapshots to sort of manage how the simulation runs. And then under the hood, those little functions I showed you earlier are basically getting dispatched to Firecracker. So the same thing that runs Lambda. And so they're all running in little jails and in very high degrees of parallelism.
Okay, sounds cool. So throughout the presentation, you mentioned Git repository, or you said it's like a Git repository. So is there a Git behind
No, there is not. Yeah. So again, think of it as this is part of the transition of thinking about it less as code and more about model. So like, you know, when you think about what gets checked into Git, like you don't check in your database to Git, right? And if you did, we would call you foolish, right? And this is roughly the same. Like what's happening is you have this live representation of these models. They're changing all the time from all sorts of sources. So change sets give you a lot of what you needed from Git in terms of branching, but they also buy you a bunch more. So like, you know, when you write a bunch of infrastructure as code and then you make a new branch and somebody else merges their branch first, right? And then you have to rebase against what they have done and make sure that you don't overwrite state. Like all of that is gone. So essentially by using this change set mechanism, what we're able to do is track the changes you've made, both by interacting with the model, but also by the code that runs the model, which is itself part of the model, which I know gets recursive, but it's all built the same way. The end is that we can basically give you back everything you got from source control plus more, because we can keep track. That audit log, for example, is the equivalent of doing git log, but what it's telling you isn't just the operations that a person took or what was in the commit. It's actually telling you every single thing that happened, regardless of how or where it learned that it happened, right?
Okay. So then another question is, you know, in infra's code, you can easily create versions of infrastructure, so you can manage multiple environments, stuff like that. How do you
Yeah.
go about this in System Initiative?
Yeah, so check it out. So the thing that we showed you a second ago, where we were like pulling in the infrastructure. So let's say that this infrastructure that's on my screen is the one that we wanted to turn into something that was repeatable, right? So what we would do is this, we'll just highlight it. Let me create a change set. So we'll just highlight it all, and we're going to go to create template.
Mm-hmm.
So here we have like our actual, all of that infrastructure we built, and we've just translated it from the model into source code. Yeah. So this is similar to what you would do in like Unity, right? When you build a macro or you want to dive into the code that's behind a shader, right? So same thing happening here. So we could extend this to sort of add variables, but one of the things you can also do with it is then basically set those things up to create PerfectScale. So now we have one of these we can drag over. So it has now variables we could set, right? So if we added some variables, some values to this, what would then we could use that to templatize the results. And then we can split that up into what are essentially environments. So if you think about like dev or QA, right? We can be like, hey, here's dev, here's QA. And then when we run this function, what it'll do is basically create another version of the same object, only in a different point of view for each environment, and then manage them across, manage those values across, and then you call component sync, and then it'll synchronize the actual infrastructure in a way that's like idempotent and convergent. So you use the same basic fundamental primitives to drive it across environments. What's interesting is that once you have data, instead of just the infrastructure model, a lot of the things that you want to do across environments become easier to express because, like, for example, application deployment, maybe you don't want to recreate the entire infrastructure. You actually just want to call a couple of bespoke actions. So you can encode those in these same management functions that create these templates to be like, hey, here's my specific application deployment model and how I interact. So you can encode them in multiple different ways. But that's how you do it.
Okay, interesting. So we have another question from the audience, and that's the one that was asked in the beginning. So basically it goes, what do you think about AI agents that in the future it can replace DevOps? I mean, train a really good AI agent can work as a DevOps. And,
Yeah.
okay, so I think you got the question. I want to add something to that. So, today most ops DevOps people out there, they also use AI code generators.
Yeah.
Nobody writes Terraform from scratch anymore. You go to Claude or ChatGPT, you name it, and you ask to generate a Terraform script.
I think you'd be surprised, but yeah.
Yeah,
But I get your point. Yeah.
especially the junior folks, that's what they do. I asked around.
Yeah.
And so the question is, how can I use an AI agent with system initiative to make
Yeah.
me more productive?
Yeah. So there's sort of there's a couple different answers. So at the layer of code generation, you can obviously use it to just do code generation. So we were showing you the editor from inside System Initiative, but you can also just mount that as a file system and then, use your editor and whatever you're comfortable with, right? You want to use cursor, go ahead, right? Like you can edit the code however you'd want to. I think more fundamentally though, to the question of like, can we get to a point where like AI can replace DevOps or why do I have to think about it? Like, I think it's important to think about what we're talking about less as magic and more as technology. And so the question to ask is like, what is the technology good at today? And then where can we use it to accelerate us as in the actual things we're trying to accomplish? And then where are its limitations so that we understand what needs to be built for tomorrow if we want to have a system that works in a particular way. I think the biggest question around sort of AI agents and infrastructure as model, like by having a model you can ask questions about, right? That's a hugely good thing for AI agents, right? Being able to say, hey, I don't know what the system is. I don't need to build a specific thing where the AI understands PerfectScale. I just need to build the model and system initiative that describes what PerfectScale can do. At which point now an AI could drive PerfectScale because it understands how to drive system initiatives model of what it means to automate something, right? So that core question of like, what's it mean to automate something? That's like the fundamental thesis of system initiative is like, we lack that model and you need one. AI also needs one. right? This is why you wind up having a bunch of difficult answers even when you start asking it to like write some Terraform for me. It'll get it rightish, you know? And then it sort of then your job is yeah, exactly, a little, and then your job is to debug it, right? So it sort of drops you into the like deep end of the pool. And that's because the models are incomplete, right? We don't actually know what you can or can't do with this thing. We don't actually have a lot of evidence or a lot of data about how they evolve over time. So that's part one. So obviously you expose that data and then you can use an AI to help you work with it. But you saw Nick work with me in that demo, right? And that's
Yep.
how an AI agent would work with you in System Initiative, right? Because what you would actually ask it to do is some work, and then it would work like a person would, and you would see the results in a change set, and you could inspect what it was doing and see the relationships that it built and understand how the model works and see it qualify itself, right? It would understand that if a qualification failed, it needs to loop back, read what the output was, then figure out how to fix it. Like if you think about how to program that AI loop with existing tooling, your brain will explode. And when you think about how to build it with System Initiative, it's kind of straightforward, right? And that's because you need a model in order to drive it. The other, another aspect of this is the more like fantastical one, which is like, can I just tell it I want to do some stuff? And then it just does things for me like magic. I think the answer to that one is probably no, without new technology. So, what it's good at right now is data transformation. So it's good at saying, right, I can take data from one shape and translate it to another. I can interrogate the information I have, get some information. It's good at that. We use, for example, AI to augment the AWS specifications because there's a bunch of stuff in the specifications that are only in the documentation, but not actually in the spec. So we pass all their documentation off to AI, extract that information, then encode it into the model. So like but we don't really have the technology that would allow us to then build a system that thinks about the results and then makes good choices. And that might evolve to be a thing we can have. People talk about like agentic programming or whatever. If you've actually tried to do it, I think you see the limitations of this path. That doesn't mean we'll never get there. It just means you're probably not getting there without. I don't think you're getting there without something like System Initiative that can provide you some fundamental model that thinks about how you automate stuff. And once you have it, actually asking it to control complex systems, I think you're a ways away, at least without approvals, like you're going to want to be able to see what it would do. You're going to want to approve it, all of which again sort of points to this idea that what you need is an infrastructure model.
Yeah. And it's also limited by our ability to define what good choices are.
Yeah, I mean, look, in the early prototypes of System Initiative, this is where we started. So what I initially thought was wrong with DevOps was that we had to have too much information about in order to get what I wanted. And what I wanted to be able to say was, as people, we say, I want to deploy that application. And I was like, how do I make it so I can build a system that understands that phrase, something like it, and then sort of does it, just does what you ask. And we built one from these really high fidelity models, right?
Mm-hmm.
And it sucked. And the reason it sucked was because asking this little ML system we built to do that it was like playing golf. You were like, you had to find like the miracle set of constraints that would do exactly what you wanted it to do. At which point it would have been better to just say what you wanted. Do you know what I mean? Like it's just better to be like, no, I knew exactly what I wanted, which was I wanted this load balancer. I wanted it connected to these things. I wanted it configured in this way. And so it wasn't better to just constantly ask the system to be like, find the exact smallest set of constraints that get me precisely what I desire. And the number of infrastructure problems that aren't that shape are very small, right? Like they're all toys and they stay toys because anything that matters immediately exceeds your ability to do that.
Yeah, yeah, that's exactly the reason why almost all paths out there failed. Like
in the end, right? And it's why the structure of paths, like back to theory, it's why paths can't actually solve the problem, right? Because fundamentally, like it needs to be able to adapt to the more complex scenarios. And the way that it tries to adapt is through abstraction, right? It tries to build a closure over the top of it and says, nobody actually needs to see all those gory details. I just want to deal with the top. And you might have noticed, like when we expanded the templates, what you saw was the resulting infrastructure. And like, you don't always want to see it at that level, but when you do, it's great because now I don't have to encode every possible variation, right? You can be like, this is what a standard one looks like. If you need to tweak it because it's just data, right? You can change it and then I can react to that change and I can write programs that manipulate the information. Like all that becomes possible. And right now it's incredibly hard, right? Like what's the
Yep.
recursive loop for editing your Terraform? I don't know.
Okay, one last question relevant. Is the model usable with Azure or other cloud providers? Where are the user account credentials that are required to create a resource in AWS stored?
Yeah, two good questions. So right now our focus is AWS, but you can build models for whatever you would like. Azure is number two with a bullet when we talk to people. Like everybody we hear Azure support the most, then it's GCP, then it's sort of a long tail of other services. So we'll get there. We'll get to Azure and those things, but right now it's just AWS. Um, in terms of where the credentials get stored, so you store your own credentials. Um, so basically we have a built-in secret system that uses these same primitives that basically does what Vault does in terms of like allowing you to define a credential and then we encrypt it in the browser, send it to us, then we encrypt that for cold storage, and then we decrypt it right before we inject it into the VM that needs the credential. So all of that is to say, you provide the credentials to us, and then we store them, and then we execute them on demand. Obviously, in like more complicated deployments or large enterprises, like that stuff happens in your house, not ours. Blah 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 blah. But
okay, so do you also support like single sign-on scenarios, stuff like that?
yeah, yes. Single sign-on scenarios, assume role policy, all that stuff.
Okay, good to know. Okay, I think we're done with the questions. And while you were speaking, I pulled up the finishing slides. So basically, this is to say, first of all, thanks for coming. Thank you, Adam. Thanks, Nick, for the great demo. Looks exciting. Definitely requires us to think differently about how we create an automated infrastructure today. We'd like to hear back from the audience, I think, to learn if they already tried System Initiative or if they're looking at it. And if you're gonna try System Initiative, please talk back to us or talk to Adam.
Yeah, for sure. I'm Adam at systeminit.com. Keeb is Keeb at systeminit.com. You can find us on Discord. We're easy to get to.
Yeah, and this was sponsored by PerfectScale, of course. PerfectScale is the continuous optimization platform for your Kubernetes clusters. So if you want to run your Kubernetes workloads as reliably and as cost effectively as possible, definitely sign up at www.perfectscale.io, connect your first cluster, and start optimizing. And yeah, there is a QR code here that you can scan in order to go to our website. Any final words, Adam or Nick?
No, thank you so much for having us. Thanks for letting us yammer on. If y'all have questions, we're happy to answer them, and I really appreciate you.
Okay, thanks a lot. Thank you, everybody.
Thank you.
And we'll see you at our next webinar next week. Actually, yeah, there's a webinar coming next month with John Willis.
Yay!
The one and only, yes.
Who doesn't love John Willis? You should absolutely come to listen to John Willis.
Yeah, and if you know the future of AI,
thinking about all these problems.
Yeah, interests you, then definitely come to that webinar.
For sure. Thanks.
Bye.